I have had the chance to go over examples like this that are a little more mathy with several of you, but I wanted to make sure that all of you had an opportunity to see some of the tricks that we can use for solving things. This is similar to example 3 with momentum. The only difference is this time I've changed it to where I don't know what that final velocity is, and I don't know this angle. So we want to remind ourselves of a couple of things. The way we can look at this is I can change this into an XY coordinate system, or oftentimes you'll see this, the north, south, east, west. So this car is going 10 meters per second eastbound, and this car is going 5.5 meters per second northbound. So we want to know what the final velocity and the angle of that collision is after they hit. So I can look at this and be like, okay, I need to remind myself that just like our forces, these things are in components. So if they're in components because I have something all on the Y and something all on the X, then I need to have momentum summed up in both the X and the Y before I can do anything with it. So I can come down here, yeah, let's go with this one. And go, so the sum of my momentum in the X, what do I have? Well, I only have, let's define this as positive. I only have this 2,000 kilogram car in the X. This one is all in the Y. So only this one gets considered here. So let's call this 1 and this 2. So I'll have mass 1, velocity 1 is going to equal, here they've stuck together. So this is an inelastic collision. So mass 1 plus mass 2 times velocity prime. But this one here, I want the X component of that momentum. So the X component of the momentum here is going to equal the X component in the end, or the sum of them if I have more things going on than that. So this here, let's see, that's touching that angle. So that is cosine of theta. And I'm done. That's it for the X. Now let's look at our Y. And the Y I have, let's see, mass 2 is the only thing in the Y. So mass 2, velocity 2 equals, once again, the sum of the masses because they've stuck. That hasn't changed. My V prime, that's still the same. But this time, I want the Y component of that velocity. So the sine function, opposite side. So sine of theta. And you look at this and you'll think to yourself, okay, I know these 4 quantities there. I know the masses and the velocities, same thing. So I know these 2 pieces. But if I take these as individual things, well, at this point here, I know those, but I don't know that. And I don't know the trig function. I don't know what this theta is. So that means that I need to combine them. Now, the one thing I can't do is that trick that I've been showing with energy, the conservation of energy. Because remember, energy is not conserved in an inelastic collision. So your exam question has you dealing with these things in terms of forces, having to supplement that with the information that you have. In this one, I'm not going to give you that. We just have momentum. But we have enough, believe it or not. So here's the trick that I want you to key in on. Excuse me. That when you see a sine and a cosine, think about dividing the 2 equations by themselves, by each other. Because if I divide sine over cosine, or if, I'm sorry, if I put sine over cosine, then what I have is a tangent function. So that would make this condense down into one trig function. And if I'm dividing this whole shebang, well, gosh, these quantities are going to go away, and these quantities are going to go away. So let's see what that looks like. So I want to put sine up top. So I have m2 v2 equals m1 plus m2 times v prime, sorry, not v1, times sine of theta. And I'm dividing that by m1 v1 equals m1 plus m2 times v prime cosine of theta. Now what happens? There's a whole bunch of stuff that cancels out here. My masses cancel. My v primes cancel. Sine over cosine, well, that's just tangent. So now I have simplified this down nicely. So this thing becomes then mass 2, velocity 2 over mass 1, velocity 1 equals tangent of theta. So now I can put these two things in my calculator. I'm going to take the arc tangent of mass 2, velocity 2. So 3,000 times 5.59 divided by 2,000 times 10. And I button push that and I get 39.99, otherwise known as 40 degrees. Nice. So now the last step here is I want to know what that V prime is. Now we're just down to algebra. I know this angle, so I can choose either one. There's no approach here that's incorrect. Whichever one I want to choose that makes me happy, I can do. But I just need to isolate algebraically to get to that V prime. And so what I'm going to do, I'm going to divide M2V2 by M1 plus M2 times sine theta. Again, if you did it with cosine, that would be fine too. So I have M2V2 divided by mass 1 plus mass 2 times sine theta. And that will give me my V prime. So I put that into my calculator and I get that V prime is 5.22 meters per second. Sweet. And that's it. So the trick that I wanted to show everybody is this one, that we can divide equations by each other. And if it makes you feel uneasy, essentially all you're doing is setting these equations equal to each other. This is just jumping to that arrangement. So the one time you don't want to do this is if I have like a 0 over here, because all of a sudden it takes this math quantity out and then things don't equal what you think they equal. And so that becomes a problem. So don't do that. But if I have values on this side and I have a nice setup that is consistent with my trig functions on this side, it's a great time to use this.